This is a lecture on differentiation. Firstly, let us look at rules of differentiation. So consider a function y equal to ax raised to the power n. First thing to note here is that y and x are variables. A and n are constants. So a could, for instance, take the value of 5 and n could take the value of, for instance, 4. They are any constants. The derivative of y with respect to x, which we call dy dx is read as derivative of y with respect to x. In differentiating y with respect to x, we take the index n and we drop it to the front and multiply with the coefficient a. So the new coefficient becomes a times n, and in differentiating we also subtract 1 from the index, so the new index becomes n minus 1. So if y equal to ax raised to the power n, then the derivative of y with respect to x, which is dy dx, is a times n times x raised to the power n minus 1. So for instance, let's look at a few examples. So if y equal to 5x raised to the power 4, then we can obtain dy dx by dropping the index 4 to the front and subtracting 1 from the index. So 4 minus 1 is 3. So we have the answer 20x cubed. Let's look at another example. If y is equal to 10x cubed, the derivative of y with respect to x is 10 times, we drop the index to the front, so it will be 3, and we subtract 1 from the index, so 3 minus 1 is 2. So the answer would be 10 times 3, which is 30 x squared. Let's look at another example. Y equal to 10 on x squared. Now this function on the right hand side, that expression on the right hand side, is in terms of a fraction. It is convenient to write this as a non-fraction, so we could apply the rule directly. So 10 divided by x squared can be written as 10x raised to the power minus 2. We simply negate the index when you take a term from the denominator to the numerator. So we can now write the derivative of y with respect to x would be 10 multiplied by, we drop the index to the front, so minus 2 comes up to the front, x, and we subtract 1 from the index, so minus 2 minus 1 is minus 3. So we have the answer minus 20 x raised to the power minus 3. Let's look at another example. Here we have y equal to 6 square root x. It's convenient to write square root x as x raised to the power half. And let's differentiate y with respect to x. So dy dx, we drop the index to the front, so we have 6 multiplied by half, and x, we subtract 1 from the index, so half minus 1 is minus a half. So we have the answer 3x raised to the power minus half. Let's consider another example. If y is equal to 6x squared plus 3x raised to the power 4, now in differentiating the function y, we can differentiate these individual terms and we can sum them together. So derivative of 6x squared is 6 times 2 x raised to the power 1 because we subtract 1 from the index. Before subtracting 1 from the index, we drop that index to the front, so 2 comes out the front, so 6 times 2 we have, and x raised to the power 1. And when we differentiate 3x squared, so we drop the index 4 to the front and we subtract 1 from the index, so 4 minus 1 is 3. So we have the answer 12x plus 12x cubed. Given y equal to 6x squared plus 3x raised to 5, we want to evaluate dy dx at x equal to 1. So we need to evaluate the derivative of y with respect to x at x equal to 1. So before we evaluating the value of the derivative of y with respect to x at x equal to 1, let's find the derivative of y with respect to x. So derivative of y with respect to x is then we will drop the index to the front, so we have 2 coming out of at the front. X raised to the power 2 minus 1 is 1 plus 3 times 5 x raised to the power 4. So we have 12x plus 15x raised to the power 4. Now we want to evaluate this derivative at x equal to 1. So if you substitute x equal to 1, we have 12 times 1, which is 12, plus 15 times 1 raised to the power 4 is 1. So 15 times 1 is 15. So we have the answer 27. So derivative of y with respect to x evaluated at x equal to 1 is 27. So let's consider another example. If fx is 6x raised to the power 3 on 2, then find f dash x. F dash x is another way of stating we are requiring the derivative of f with respect to x. So f dash x is simply the derivative of f with respect to x. So we need to differentiate the right hand side with respect to x. So it is 6, we drop the index to the front, so times 3 on 2, x, we subtract 1 from the index, so 3 on 2 minus 1 is a half. So we can simplify the expression as 9x raised to the power half. So if fx equals 6x cubed plus 5x, then find f dash 2. In other words, find the derivative of f with respect to x, that's f dash x, and then evaluate f dash x at x equal to 2. That's what f dash 2 implies. So derivative of f with respect to x is 6 times 3 x squared plus 5. So we have 18x squared plus 5. So now if we evaluate f dash, the derivative of f with respect to x at x equal to 2, we need to sub in x equal to 2. So we have 18 times 2 squared plus 5. 4 times 18 is 72 plus 5 is 77. Example 8, if fx is a constant, so fx is 5, then find f dash x. Now derivative of a constant is 0. We could also understand why a derivative of a constant is 0, because phi can be written as phi times x raised to the power 0, because x raised to the power 0 is in fact 1. Now if we differentiate fx with respect to x, you drop the index 0 to the front, which gets multiplied by 5 to get the answer 0.